The truth about GCMS accuracy, what detection limits actually mean in real testing. A regulatory submission was 3 weeks from its filing deadline when a residual solvent result came back flagging in an impurity that wasn't there. The method was technically valid, the instrument had passed calibration, but no one had accounted for a matrix interference that was pushing background noise into the detection window, and the data looked real enough to stop a program called. Hi, I'm Raghuveer Singh Parmar, Director at Scientific Affairs at Resolve Mass Laboratories, where we run analytical testing for pharmaceutical and biotech companies, navigating IND and ENDA submissions. And GCMS is one of the most consistently misunderstood tools we work with every day. The truth about GCMS accuracy. Here is what most teams get wrong. GCMS accuracy isn't a property of the instrument, it's the property of the system, the method, the sample preparation, the analyst, and the matrix. When a result fails, people reach for the instrument manual. They should be reaching for the method validation package. GCMS combines molecular sensitivity with structural specificity in a way very few analytical technologies can match. But that combination creates a false sense of scrutiny. The instrument confirmed it, so it must be right. That assumption had derailed more than a few programs. What makes GCMS so accurate? The architecture of GCMS is worth understanding because it explains both its power and its limits. The gas chromatograph separates compounds first, physically sorting them by volatility and interaction with the column before anything reaches the mass spectrometer. The MS then identifies each compound by its molecular fragmentation pattern, essentially its chemical fingerprint. Think of it as a two gatekeeper system. A compound has to clear chemical separation and molecular fingerprinting before it's confirmed. That two-step verification is what makes GCMS so defensible in regulatory environments and so revealing when something slips through unexpectedly. Why industries trust GCMS? This is why GCMS sits at the center of pharmaceutical testing, environmental monitoring, and forensic science. Regulatory agencies accept it, courts rely on it, the data it generates is expected to hold up under serious scrutiny, which means the pressure on a GCMS method is not only scientific, it's the legal and regulatory. A result in a pharmaceutical submission doesn't just have to be correct, it has to be demonstratively correct, backed by documented evidence that the method is genuinely fit for the purpose in that specific application. Understanding GCMS sensitivity. Modern systems can detect compounds at parts per billion and parts per trillion levels. That's a genuine validated compatibility, and it's precisely why GCMS is irreplaceable for trace contamination and safety testing. But sensitivity is not the same as accuracy. Detecting a signal at low concentration and correctly attributing that signal to the right compound at the right level are two entirely different things. This is where teams with limited method development experience tend to run into most troubles. Detection limits explained simply. 3 terms define where your method actually lives. LOD, the limit of detection, is the lowest concentration you can distinguish from the background noise. LOQ, the limit of quantitation, is the lowest can reliably measure. not just detect. And MDL, the method detection, limits faults in the entire analytical workflow, including the sample preparation, which is often where the real world variability enters your data. These are not fixed instrument specifications, they shift with the matrix. A method validated cleanly in solvent solution does not automatically transfer to a pharmaceutical formulation, and assuming it does is one of the most common errors we see arriving in analytical packages for regulatory review. We once received a method transfer from a team with excellent GCMS data, solid calibration, good precision, clean chromatography, all of it generated from their API in neat solvent. When that same method was applied to their finished dosage form, spurious peaks began appearing that bracketed their critical impurity. The excipients were coeluting. The method had never been challenging in the actual sample matrix. 3 weeks of revalidation followed, work that a single matrix scouting experiment at the outset would have prevented entirely. What impacts GCMS accuracy? 4 factors drive GCMS accuracy in the practice: calibration quality, the use of internal standards, sample preparation discipline, and analyst expertise. Calibration and internal standards are the most visible. They appear in your data files and your uncertainty calculations. Sample preparation and analyst judgment are invisible until something goes wrong. An experienced analyst notices a peak-shaped anomaly and questions the result before it leaves the lab. A less experienced one records the number. Sensitivity versus specificity. The distinction matters more than what teams realize. Sensitivity without specificity gives you signals you can't trust. Specificity without sensitivity gives you method that misses what it needs to find. GCMS, when properly validated, drives both. The quantifier is always when properly validated. So when GCMS works best? GCMS is ideally suited to volatile and semi-volatile compounds, residual solvents, organic impurities, flavor compounds, and degradants that fail within the right volatility window. For regulatory and legal contexts, it produces a chain of analytical evidence that holds. It's not the right tool for inorganic analytes or involatile compounds, and applying it outside its range is a recognized misapplication that adds timeline risk without adding data quality. So let's talk about key takeaways from this session. 3 things worth carrying from this. GCMS is powerful when method is validated for the matrix, not just the molecule. Detection limits are not instrument specifications, they are method-specific thresholds established through experimental work in the relevant sample type. And the analysts interpreting your GCMS results matter as much as the equipment generating them. If GCMS is part of your analytical strategy for an INDA or any INDA program, the method validation conversation is worth having earlier, not 3 weeks before the deadline. At Resolve Mass Laboratories, we have worked through these challenges across a wide range of molecules, matrices, and regulatory contexts. If you'd like to talk through where your method stands, reach out through our site or our website, leave a question there, or leave a question in the comments below. We would be happy to have a conversation. Thank you so much for watching this session, and see you in the next one. Until then, goodbye for now.